All right, so let's do a discharging a capacitor example. Let me draw a circuit where I have a capacitor and a resistor, and then I have an open switch. And I'm going to say that this switch closes at t equals 0. And I'm going to say that I've got a 1K resistor and I've got a 100 microfarad capacitor. Okay. And I am going to say that my initial condition here, this is my capacitor voltage, right? I'm going to say that VC of t at time t equals 0 is going to be equal to 5 volts. Okay, so my capacitor in this case is initially charged to 5 volts. Okay, and so what I'm going to do is I'm going to close this switch right here at time t equals 0, which is going to connect this side of the resistor to 0 volts. And so I'm going to have 0 volts here and 5 volts here, and that's going to create some current flowing through the resistor, which is going to ultimately cause the discharge of my capacitor. I'm going to get behavior that looks just like this, which is what we derived previously. Okay, and so without going back to look at that slide, I'm going to write down that the discharging capacitor equation for the voltage, VC, is equal to VCI, which is my initial voltage, which in this case is going to be 5 volts, multiplied by e to the minus t over RC. Okay, that's my discharging equation. And so the question I want to know here is, at t equals 150 milliseconds, what is VC? All right, and so all we have to do is use our handy equation here, and we can go ahead and plug some values in. So VC of time t equals 150 milliseconds is equal to VCI, which in this case is my initial voltage, multiplied by e to the minus t, which in this case is 150 milliseconds, over RC, which is 1K, multiplied by 100 microfarads, which is 100 milliseconds, okay? And so let me go ahead and just throw this into my calculator. E to the answer multiplied by 5, and I get that VC of t equals 150 milliseconds is equal to 1.12 volts, roughly. Okay? And so what I've basically just done is, just to make it super clear, is I've derived this expression here. Well, I derived it previously, but we're just using it now that we know this is the discharging expression. That is the expression that gives us this discharging behavior. I know that all times leading up to time t equals 0, my capacitor voltage here, I'm going to plot VC of t, is equal to 5 volts, right? It's 5 volts all this time. And then at t equals 0, my switch closes, my capacitor starts discharging, and it follows this curve, right? And after about 5 tau, that's exactly, oh, you know what, this is a pretty inaccurate drawing. It would look something more like this, probably. But after about 5 tau, I have discharged my capacitor pretty completely. But I am not interested in that 5 tau, which would be 500 milliseconds. I was interested in 150 milliseconds. So let's say that was about here. It's not drawn to scale, but at 150 milliseconds, we just determined that the voltage across our capacitor was 1.12 volts, which is what we determined right here. Okay, so that's our little discharging a capacitor example. In the next video, I'll go ahead and just solve another example just to make sure that this concept makes sense and it's pretty clear to everybody.